So question 16. This is a fairly good question, very challenging one, I have to say. It is, however, scaffolded, so bits that you're going to use in the first part are very relevant when you're trying to solve the last part, but you'll see that when we get to it. So the first part you have to do is show that the area of triangle ABD, the ratio, of the triangle ABD to CBD is equal to the length of the line AD to DC. So the area of this, that's ABD, and we're dealing with the area of this here. Okay, so I mean, the first thing you got to do is use your basic formula for the area of a triangle. So the area of ABD is going to be equal to half the base by the perpendicular height. So there's your perpendicular height, we'll call it H. So it's half the base, which is AD, by the perpendicular height, which is H. And the area of the other triangle, BDC, is equal to half the base. The base of this triangle is DC. And you'll notice again that the perpendicular height of this triangle is the same H. So if we were to examine those as ratios to each other, we would have on one side half AD H, and on the other side we'd have a half DC H. So you can see clearly that you've got H's on both sides, you have a half on both sides. So what you're actually left with is AD to DC. That's what you've been asked to show. So, like I said, we'll come back to that when we're looking at the last part of the question. So the second part of the question, it says, show that the area, ABCD below is a trapezium. Prove that the area C equals the area D. So I've got two triangles here, two trapeziums. So I can just highlight the triangles I'm talking about. There's triangle ADC, and the other triangle we're going to be dealing with is this triangle here. And the thing you'll notice about these two triangles is that they have the same base. And because these two lines are parallel, the distance from here to here is the same. So they've got the same H's. So we've got a H here and we've got a H here. They're the same. So they're the same base, same perpendicular height. So that means that the areas of those two triangles are the same. So the yellow triangle is equal to our pink triangle here. So triangle ADC, triangle is equal to triangles. The area of triangle ADC is equal to the area of triangle DCB. And the area of triangle A is, ADC, this triangle here is C and B. And that's equal to this triangle here, which is D and B. Okay, so in other words, we have C plus B is equal to D plus B. Now, since B is the same on both sides, we end up with C is equal to D. So that's it done. Area C equals area D. Fairly straightforward once you identify that the two triangles are identical. There are other ways to go about showing that those two triangles are identical. I mean, if you want to show congruency, you've got your SSS, ASA, side angle side, or HS, and you could have went about trying to show that these triangles were identical another way, but the quickest way of doing this question by far is this approach here. So moving on to the last part of the question. Now, this is not so straightforward. You need to really be tuned into the fact that what you did in part I is relevant here now. So I've got the figure for part I, figure 1 down here, so that we can look at it again. Okay, so what they've asked us to show here is that the area of the trapezium ABCD is equal to A plus B plus 2 times ABD. Now, we know that the area of trapezium is equal to the 4 areas. So I'm just going to write A, B, C, and D rather than areas. But it's A plus B plus C plus D. Okay, those 4 areas, just so we're clear, right? A plus B plus C plus D. So somehow we have to convert C, the area of C and the area D into this here. Okay, now what we learned in the first part I of this question was that when we have a triangle, this line here, okay, ends up bisecting this line, dissecting this line here, and the ratio of this line here equates to the ratio of the areas of the triangles. That's what we found out. The length of the line AD, the ratio of that was equal to the ratio that the areas were in. And we have to now use that by studying this. I suppose first thing you do is look at your lines. You've got 2 lines here that we can play with. We can play with this line here that runs this way, or we can play with this line here that runs up this way, the line DB. Okay, so we'll play with that one there, right? Call that X, Y, Z, anything. Just call the intersection there a letter. Now, so using what we learned, we know that the area of let's look at these triangles. So this we'll examine this line here. There's the small side and there's the large side of that line. Okay, so that line there is splitting up these areas here into a ratio like we had in question in part I of the question. So the area of C, for example, over A is equal to the ratios of D to X. So that's the little side over the large side would be X to B. Okay, just like we had down here in this question. So C over A is equal to D over X equals XB. And if we were to look at the other side of our trapezium, so that's taking care of that and that. Let's look at this here. We've got the same thing. We've got the same line creating with 2 triangles and 2 areas. So we can say the ratio of this over this is going to be equal to dx over xb. So again, the small side, in this case, it's b, the small area. When we look at this triangle here, the small area is this one here. So that's going to be b. That's going to be b over d. So we're getting this c over a is equal to dx over xb, which is equal to b over d. So these are these ratios. So let's just move forward with our letters and cross multiply, and you will get CD is equal to AB. So these are areas. So the area C multiplied by the area D is equal to the area of B multiplied by the area, the area of A multiplied by the area of B. Now we know that the area of C and the area D are the same. We've already shown it in part 2 of the question. So you can then say C, that this is the same as C squared is equal to AB, or you could say it's D squared is equal to AB by substituting in either C for D or D for C. So C by C is equal to AB. And of course that means that C has to be equal to the square root of AB. and D would have to also be equal to the square root of AB. So now you can go back up to your original thing. So we had A plus B plus C plus D, which now gives us A plus B plus the square root of A, B plus the square root of A, B. So instead of C, it's the square root of AB, and instead of D, it's the square root of AB. So you add those together, you get A plus B is equal to 2 times the square root of AB. And that there is equal to, plus 2 times the square root of AB. And that there is equal to the area of trapezium. So I suppose I got a bit messy there with that presentation, but okay, that's your answer.